So we've covered our powerful processor, we have our high-end video, and now we want to talk about having our maximum RAM for our workstation. When we're talking about our maximum RAM, we mean that we want to get the maximum amount of RAM we can place on that motherboard, that motherboard in our processor will support. Typically, we want this to be at least 8 gigabits or greater, and we want this to be either DDR2 or DDR3 RAM. Obviously, with our preference of the two being DDR3 if possible. Now, again, memory is one of those things that if we're running on a 64-bit operating system, the more the better when it comes to what our motherboard can support. The amount of memory that we have allows us to prevent having to swap to our hard drive. It can pull that information from the hard drive and store it there while we're processing it. It makes it a lot more accessible, and we don't have to constantly be going from our memory to the disk drive in order to pull that information. So 8 gigabits is really our minimum there if we're using a high-end graphics workstation. We want more if possible. 16, 32, anything higher is better, obviously. We also want to make sure that we're using paired memory, and all this really means is that when we're purchasing our memory sticks, we don't want to say, okay, I have 6 slots on my motherboard and 6 slots, 3 banks. I don't want to buy them in sets of 2 because on my motherboard, those 6 slots, banks of 3, sometimes they'll actually be color-coded, and we'll use our black and our blue here. We don't want to fill up those 6 slots with a pack of 2 that we bought into these 2 slots, a pack of 2 that we bought separately at a different time into these 2 slots, and a pack of 2 that we bought separately at a different time into these 2 slots. Using the paired memory means that for optimal performance, we want to buy the exact same memory, particularly at the exact same time from the same manufacturer, and we want to buy it in pairs that match our memory banks. So we use this first bank, our black color-coded bank, and we buy a set of 3 sticks that are matching memory. And then our blue bank, we buy another set of 3 sticks that are matching memory, at least minimally with our blue bank. This, again, allows us with optimal performance because those memory sticks will have matching clock speeds. They'll be more in tune with each other because they're actually matching sticks from matching manufacturers, and we'll see better performance than, say, if we bought, especially if we bought 6 separate sticks from 6 completely different manufacturers that are running at 6 completely different clock speeds. Sometimes we may even run into situations where our computer can't handle that difference and it won't even boot. We want to make sure that we're matching them as closely as possible, and at least we want to match them within the banks. We want to make sure that they're the same memory from our same manufacturer. Moving on from our memory, we want to use at least a full ATX motherboard. The reason for this being that it will give us a greater slot. We have room on this ATX motherboard for at least 2 PCIe X16 slots, and these are going to be our largest PCIe slots, and we'll have 2 of them. We'll have 2 or more of our PCIe 1 slots, and we'll also have at least 4 standard PCI slots. Also on our ATX motherboard, it gives us more expansion room for our high-end RAM. We have more slots there than, say, on a micro ATX board. We'll have more availability, and we want to try to include built into our ATX motherboard at least a few USB 3.0 and a SATA 3 connections. Both of these are the highest of their class at transfer rates of transferring transferring data. And this comes in handy, say, when we're creating a graphical design project. We need to save that onto our disk. We need to save that onto a USB drive. That's going to give us a much quicker transfer rate to our storage device and a much quicker read rate from our storage device than a USB 2.0 or 1.0 or our SATA 2 or SATA 1. We want to make sure that we're getting that optimum performance, especially now that we're investing in this. One of our final considerations for our graphic workstation is going to be the actual case that we have it in. We want to be trying to get an ATX full tower. We don't want to try to jam all of these different graphical and high-end processors and maximum RAM into a small space. We want to try to get an ATX full-size tower or a custom full-size tower. Now, this full ATX tower, not only will it allow us to have plenty of slot space on the front of our machine for additional optical drives, additional Blu-ray drives, whichever we may need, it'll also give us better cooling capability. We have a lot more space for actually sending cooling through our desktop, through our tower, or not our desktop, our tower station, and that'll keep our computer running at maximum performance because we have that good cooling. Keep in mind that a metal tower, a metal casing, works better at cooling, works better at conducting that heat away than, say, a plastic tower or plastic casing. Additionally, with our full ATX tower, with all of these different components that we have, we want to look at a power supply unit of at least 750 watts. So we erased some of our components already, but we talked about how we want to have our high-end processor, our high-end video. We also have max RAM, an ATX motherboard, a full ATX tower, and a power supply unit, which is pushing us at least 750 watts. And this will give us a very good graphic workstation. And for a couple years to come at least, we'll be able to use this, and it may get a little bit pricey, but again, this is an investment, and it should take time and effort in finding one of these or building one yourself and putting it together. Just make sure that we're doing the research and we're getting the correct components.